Coconut farming is a tropical delight, where the iconic coconut tree thrives in warm, coastal climates. These versatile palms produce a bounty of products, from refreshing coconut water to nutritious coconut milk and oil. Cultivation involves careful planting, regular watering, and meticulous care. Harvesting ripe coconuts is a skilled task, often done by hand. Coconut farming not only provides sustenance, but also contributes to various industries, making it a valuable asset in many tropical regions. From the production of copra, the dried kernel of the coconut, to the creation of coconut oil, sugar, and fiber, every part of the coconut tree is utilized. This sustainable crop offers numerous economic and environmental benefits, making it a cornerstone of tropical agriculture. Additionally, coconut trees play a vital role in coastal ecosystems, providing shade, erosion control, and habitat for diverse wildlife. Mushroom farming, or fungiculture, is a fascinating and sustainable agricultural practice. It involves cultivating fungi, primarily mushrooms, in controlled environments. This process typically includes preparing a suitable substrate, inoculating it with mushroom spawn, and providing optimal conditions for growth. Mushrooms are a versatile crop, offering a range of culinary and medicinal benefits, from the popular button and oyster mushrooms to exotic varieties like shiitake and porcini. Mushroom farming provides a diverse and nutritious food source. Additionally, mushrooms contribute to a circular economy by utilizing agricultural waste products as substrates, reducing waste and promoting sustainability. Furthermore, mushroom farming can be a profitable venture, as demand for these nutritious and flavorful fungi continues to grow. The controlled environment of mushroom farming also allows for year-round production, ensuring a steady supply of fresh mushrooms to consumers. Autonomous underwater farming is a cutting-edge field that leverages technology to revolutionize marine agriculture. By utilizing autonomous underwater vehicles and advanced sensors, farmers can monitor and manage underwater crops with precision and efficiency. These intelligent machines can navigate through underwater farms, collect data on water quality, nutrient levels, and crop health, and even perform tasks like harvesting and seeding. This technology not only increases productivity but also minimizes human intervention, reducing labor costs and environmental impact. As autonomous underwater farming continues to evolve, it holds the potential to transform the aquaculture industry, ensuring sustainable and efficient food production from the ocean. Underwater farming can help alleviate pressure on land-based agriculture and contribute to food security in a world with a growing population. The production of cigarettes is a complex and highly mechanized process. It begins with the preparation of tobacco leaves, which are sorted, blended, and cut into fine strands. These strands are then combined with additives, like flavorings and sweeteners. The blended tobacco is fed into a cigarette-making machine, where it is rolled with paper and a filter to form individual cigarettes. These cigarettes are then packed into cartons and shipped to retailers. Throughout the manufacturing process, quality control measures are implemented to ensure consistency and compliance with regulations. Many factories use advanced technology like laser cutting and automated packaging systems to streamline the production process and increase efficiency. Despite the harmful effects of smoking, the cigarette industry remains a significant global business. Due to increasing public health concerns and stricter regulations, the industry is facing challenges and is under scrutiny worldwide. The future of the cigarette industry is uncertain, as governments and health organizations. Berry, the strawberry harvesting robot, is revolutionizing the agricultural industry. This innovative machine, developed by Organifarms, is designed to automate the harvesting process, addressing the challenges of labor shortage and ensuring consistent quality. Equipped with advanced image recognition technology, Berry can accurately identify ripe strawberries, even in dense clusters. It delicately picks the fruit, avoiding damage and ensuring optimal freshness. The robot then places the harvested strawberries directly into punnets, ready for packaging and distribution. Berry's autonomous navigation capabilities allow it to move efficiently through greenhouses, optimizing harvesting time and reducing labor costs. By working 24 hours, this tireless robot maximizes productivity and ensures a continuous supply of fresh strawberries to the market. Sheepskin leather production is a complex process involving several stages. Initially, sheepskins are cured and then soaked in water to remove impurities. Next, hair and flesh are removed through liming and fleshing processes. The skins are then tanned using natural or chemical agents to make them durable and resistant to decay. Tanning can be followed by dyeing to achieve the desired color. Finally, the tanned leather is dried, stretched, and finished to achieve the desired texture and feel. The finished leather can then be used to create a variety of products, such as clothing, footwear, and accessories. The leather industry is increasingly focusing on sustainable practices, using eco-friendly tanning agents and minimizing waste. Advancements in technology have led to more efficient, and environmentally friendly production methods. By embracing these sustainable practices, the leather industry can continue to provide high-quality products while minimizing its environmental impact. Palm oil production is a multi-step process that begins with harvesting fresh fruit bunches from oil palm trees. These bunches are then sterilized to kill bacteria and enzymes, followed by threshing to separate the fruits from the bunch. The fruits are then digested to release the oil, which is extracted through a pressing process. The extracted crude palm oil is further refined through processes like clarification, bleaching, and deodorization to remove impurities and improve its quality. The refined palm oil can be used in various applications, including food, cosmetics, and biofuels. Palm oil is a widely used vegetable oil, but it's important to ensure sustainable and ethical practices in its production to minimize environmental impact and support social responsibility. Palm oil production can also generate various byproducts, such as palm kernel oil, palm fiber, and palm oil mill effluent, which can be further processed for different uses. It's crucial to manage these byproducts responsibly to avoid negative environmental consequences. To promote sustainable palm oil production, certification schemes like the Roundtable on Sustainable Palm Oil have been established to ensure that palm oil is produced responsibly. Lely Microfarm is a revolutionary indoor vertical farming system designed to bring fresh, locally grown produce to urban and indoor environments. This innovative technology allows for year-round cultivation of a variety of herbs, leafy greens, and microgreens, regardless of external weather conditions. Lely Microfarms are sleek, self-contained units that utilize hydroponic technology to grow plants without soil. They are equipped with advanced LED lighting systems that optimize light spectrum and intensity for optimal plant growth. These systems also incorporate automated watering and nutrient delivery systems, ensuring precise control over the growing environment. By minimizing the need for pesticides and reducing water usage, Lely Microfarms promote sustainable and eco-friendly food production. They offer a convenient and efficient way to grow fresh, nutritious food in limited spaces, making them ideal for home. Wheat farming is a crucial agricultural practice that involves cultivating wheat, a staple food crop worldwide. It begins with soil preparation, which includes plowing and harrowing to create a suitable seed bed. Wheat seeds are then sown, either by hand or using seed drills. After sowing, the fields are irrigated to provide adequate moisture for germination and growth. Harvesting wheat is a critical step in the process. It was done manually using sickles or scythes. However, with advancements in technology, modern wheat farming relies heavily on mechanized harvesting. Combine harvesters are powerful machines that efficiently cut, thresh, and clean the wheat, significantly reducing labor costs and increasing productivity. These machines have revolutionized wheat farming, enabling farmers to harvest large areas quickly and efficiently. During this period, farmers may apply fertilizers and pesticides to ensure optimal growth and protect the crop from pests and diseases.